average is 92, so you can assume what your mark is around. So it's not. Yeah, most of you are getting pretty high marks. So we're gonna move on to trig identities now, the fun stuff. Okay. I don't know if I'm gonna get through one or two lessons today. I'll get through one. I'm not sure if I'll get through the other one. Tomorrow you have your quiz on unit 5. Yeah, the first 3 lessons. And then your assignment will be after the break. So you guys won't have to. That's cruel. That's mean. Okay, I wouldn't get. Yeah, the Monday you come back. Well, something's good.
Okay, well, I'd rather have it after the report.
Yeah, that'd be dope.
All right, so today we're gonna start with just some concepts that we learned from last unit. We're gonna learn about the related acute angle, but we're also gonna introduce the correlated acute angle. So when I talk about the related acute angle, am I talking about the acute angle made with the x or the y-axis? The x-axis. So if I'm going to talk about the correlated acute angle, what axis do you think I'm going to be referring to? So the angle that's closest to the y-axis.
That's crazy.
Okay.
Like this.
Yeah. So when I talk about related acute angle, let's do anything. Yep. So remember, this is my terminal arm, right? This is my related acute angle.
Is that like the y or something?
Yeah, so this is our theta, this is our beta, which is our related acute angle.
Oh.
So we would always pick the angle that's closest to the x-axis, but with this unit, let's say this is our theta over here. We're going to be focusing on this acute angle right there.
Did we learn that last year? Oh,
No.
Oh, okay.
We just learned about this one last unit. The related acute angle. Yes.
So what is it? What are its uses if you just find a correlated angle?
So the correlated angle just has to do with the basically. So say if cosine of pi over 6, you're finding the. Let me see what that term was. You're finding its cofunction. So you're trying to figure out. So when we talk about cofunctions, we're talking about sine what? So if we have sine pi over 6, what cosine ratio is equal to sine of pi over 6?
Oh,
That's a correlated acute angle. So we have a first question. So what possible equation for the function shown below? So this is our graph. We start at the minimum. And we have Kaylee, Ainsley, Sarah, and Connor are comparing their answers to their question. Kaylee's function is f of theta is equal to negative cos theta. Ainsley's function is g of theta is equal to cos of pi minus theta. And Sarah's function is h of theta is equal to cos plus pi, cos times pi plus theta. And Connor's function is j of theta is equal to sine times 3 pi over 2 minus theta. So who has the correct answer, and how would you check if they are correct?
Isn't it Kaylee?
Okay, we have one vote for Kaylee.
It's like negative stuff.
Okay.
Like you search it.
Anyone else have any ideas? So Yusuf says Kaylee.
yeah, it would make sense if it was Kaylee. It's cosine.
Jose says Kaylee.
Yeah, because cosine doesn't start at 0, right? Usually it's
Who else? Anyone else have different opinions? No, so everyone says.
I mean, Sarah's function works, right?
Sarah's function?
Wait, no. I mean, no. I mean, the one above it.
Ainsley's function.
Yeah, Ainsley's function.
Okay.
oh,
So why would Ainsley's function also work?
Because it's. I was confused because I thought that the pi was the x one, but like the theta is the x one, so it's technically theta plus pi. Technically, if you
Okay.
switch the theta.
So what does this negative theta refer to? What kind of transformation?
Can I grab my coffee mug?
Oh. amazing quotes on that much. So what kind of horizontal translation is minus theta in the bracket?
Right?
To the right.
Oh, that's not how I looked at it. Isn't it? Isn't theta always supposed to be like, isn't theta the x?
Yeah, theta is whatever angle. Theta is the x.
So then isn't it always supposed to be like positive? Something?
No, because this has to do with the translation, so it can be positive or negative in the bracket.
And so, like, for example, if it's like let's say like 2, like bracket x, x plus 4.
Mhm.
If there's another thing that's like 2 in the bracket, 4 minus x, that's the
Okay.
same thing, right?
Yeah, except you just have your x as negative. It'll still be 4 units to the right. So,
Okay.
so both Cayley and Ainsley's function work. Okay, Cayley's function works mainly because where does cosine usually start at?
1.
The maximum, right? So it goes from here to here to here, back to here. Okay. So and this function starts at the minimum. So because it starts at the minimum, it is flipped on the x-axis. So that's why f of theta is equal to negative cos theta works. Okay. Why would g of theta is equal to cos of pi minus theta work? Yeah. So in this case, our theta would just be 90 degrees to the right. Okay?
So wouldn't Theo's function work too?
No, because you're shifting it left. And remember, with a
It's still like it's still the same, though.
yeah, it could work too. So that's right, because it still starts at the top, goes down, and keeps going. So Serre's function can also work. Okay? It just depends on the value they have for our theta. So
Wait, what do you mean?
Cayley's function works, Ainley's function works, and Sarah's function work. Oh, because we don't know what value they're giving theta for this graph.
Oh, okay.
Okay? So all of these three work, okay? The first one is easy to see. The second two, you just have to look at where the peaks are in the graph. And as you can see, we have pi minus theta, which is, we're just shifting it to the right. And pi plus theta, we're just shifting it to the left. So those three functions will work for this graph. So we're going to just refresh our memories with our related acute angles. So if the angle is in standard position, the acute angle between its terminal arm and the x-axis is called the related acute angle. And we learned about this last unit. So we want to write an expression that is equivalent to each of the following using the related acute angle. And we want to check our answer using a calculator or not. We don't really need this part. Okay. So our first one is cos of 2 pi over 3. So we have to draw it out. What is pi over 3? 60. So we have 60, 120, and we have 180. So we're going to count 2 sections. 1, 2.
So you're not marking that drawing.
No, I'm not going to mark your drawings.
Okay.
So this is our theta, which is 2 pi over 3. So we need to find a related acute angle that is equal to cos of 2 pi over 3. So 2 pi over 3 is from 0 to 120. So 120 to 80, how many degrees are left? 60. Is cosine positive or negative in that quadrant? So we can say negative cos of pi over 3.
So it doesn't matter, like you can like you can say technically sine pi over 3.
That's legal.
Like, does it have to be the same like, thing?
Now you're getting into the correlated acute angle part. So that's what we're gonna talk about after.
Wait, what?
That's what we're gonna talk about after, like the
No,
cosine to sine.
Like just so for this one it's wrong.
Yeah.
Oh,
So the next one we have is tan of negative pi over 8. So where would negative pi over 8 land on in the circle? And which way are we going?
20 degrees? Let's say, yeah. Negative 20 degrees.
So this is negative pi over 8.
wait, sir.
Yes.
When we plug this in, we gotta use radians.
Yeah.
Radians.
Just for this one, for the graphing part, you have to use degrees.
Okay.
So is tan positive or negative in the
Negative.
fourth quadrant? So you can just say negative tan of pi over 8. Because our acute angle is just going to be pi over 8 again.
So
Oh,
the
right.
acute angle, no matter like what, it's always a
With the x-axis. Yep, with the one closest to the x-axis.
Okay.
So
like,
this one is closest to the x-axis. This one is closest to the x-axis.
I know, but for that one, it's because like we went all the way there.
Yeah.
So like even if it's negative, like, okay.
And then the last one we have is 7 pi over 12, or 17 pi over 12.
That should be in the third quadrant, I think.
So where would this one land?
The third?
So this is going to be just a 0, and it's going to be 6 pi over 12, 12 pi over 12, 18 pi over 12. So where's it going to land?
Third quadrant.
Third quadrant. So our theta is equal to 17 pi over 12. So we have sine of 17 pi over 12 is equal to. Is sine positive or negative in this quadrant? Okay,
Well, it's no negative.
negative. So negative sine of. So if this is 12 pi over 12 and this is 17 pi over 12, what would our acute angle be?
5 pi over 12?
Yep.
I'm getting it.
Yeah, and then I'm gonna throw you correlated acute angles, and you're gonna like,
It shouldn't be that difficult, right?
no. So
It's
you know how cos is x and sine is y?
Yeah.
So for example, if cos of pi over 6 is, let's just say, I'm just giving an example, it's probably wrong. Is it what, 3 pi over 2?
Cos of pardon.
Cos of pi over 6.
Is I don't even know. I don't have my unit circle. Cos pi over 6 is root 3 over 2.
Yeah, it was right. So cos pi over 6 is root 3 over 2. You have to find the angle at which sine gives you root 3 over 2.
So wouldn't that be sine pi over 3?
Yeah, so cosine of pi over 6 is equal to sine of pi over 3. Because they gave you the same ratio.
Okay.
Remember that chart, the chart we did with the special triangles at the beginning, where sine and cosine had the same values at different angles? That's what we're talking about when we're talking about correlated acute angles.
Okay.
But we'll get to that right now. So that's the unit circle for you. So remember, this one is pi over what?
3, 6.
6. And this one is
Pi over 3.
pi over 3, because it's 60-degree intervals.
Wait, why is it negative?
Equals
Oh,
30-degree intervals. All right. So you guys have this somewhere in your notes, hopefully. You guys
Yes,
kept it safe and sound. You guys put some a sleeve on it so that you never rip it. So when we're talking about the related acute angle, okay, we're talking about the angle closest to the x-axis. Okay, so cos of pi over 6 is in quadrant what? Pi over 6 is in what quadrant? 1.
Yeah.
Okay, so that means our related acute angle is just the same thing. So cos of pi over 6 is equal to, so we're going to put a plus or minus? Positive. And our acute angle is still pi over 6. Okay. Now we're going to do the next one. So cos of pi over 6 is in what quadrant? 1, 2, 3, 4, 5. Okay.
I thought that was 60.
So this is 5 pi over 6. No, pi over 6 is 30 degrees. And we want to figure out this acute angle over here. So is cosine positive or negative in the second quadrant?
negative.
So cos of pi over 6 is equal to? Yep. Negative cos of pi over 6. So this is so far straightforward because it's from last unit.
So I say using the acute angles in the first quadrant only.
Because that's the only acute angle closest to the x-axis. Right, because pi over 6 is this angle over here. And is this angle over here closest to the x-axis, or is this angle closest to the x-axis? Yeah. And because we didn't really move from the first quadrant, the angle is still the same.
No, but we did. It's the second.
The second one we did, because we ended up in the second quadrant. So from 0 to here is 5 pi over 6. And we need to figure out what is the remaining acute angle.
I know, but it says in the question, it's like first quadrant only, so I'm confused.
Where?
Okay,
Might be.
the question. It says find equivalent expressions by filling in the blanks.
Yeah, so these are angles in the first quadrant. That's
The
why.
second one was in the second quadrant.
I know, but because it's pi over 6, it's the, and you can, pi over 6, when you write pi over 6 and draw it out, it's in the first quadrant.
Okay.
So the next one we have is 4 pi over 3. So where does 4 pi over 3 land us?
Quadrant 3?
Yep, so
60 times. Yeah.
1, 2, 3, 4. So this is theta is equal to 4 pi over 3. And now we have to figure out our related acute angle, which lands in where?
The third quadrant.
So we need to find this related acute angle over here. Okay? So is sine positive or negative in that quadrant? Okay? And what would our angle be?
Pi over 6.
Nope. So remember, we're finding this angle over
Pi
here,
over 3.
pi over 3.
Oh.
Remember, to 180, it's 3 pi over 3.
Yeah.
And then we moved down another section of pi over 3. So you're just left with pi over 3. And then the next one, we have 5 pi over 3, which lands in what quadrant?
The fourth?
Yes, sir. It's in the fourth quadrant. So this is 5 pi over 3, and we need to find this acute angle. So is tan positive or negative in the fourth quadrant? Negative. And what is our related acute angle? Pi over 3. Let's see if you guys remember. So cosecant theta is the reciprocal of what?
Pi over sine.
He starts saying an angle and then he said the word. So cosecant is the reciprocal of sine. So cosecant is equal to 1 over sine. Okay, so now we're just going to draw this angle out. So sine of 2 pi over 3 is going to land us in what quadrant? 1, 2. So this is 2 pi over 3. And this is our, I shouldn't write theta, I should write beta. And this is our related acute angle. So is cosecant theta positive or negative in the second quadrant?
Positive.
Positive, because it's just a reciprocal of sine, and sine is positive. And what is our acute angle?
Pi over 3.
Pi
Isn't
over.
it just sine then?
Pardon?
Oh, wait. What? Yeah, you lost me. Isn't it just sine? Like, how is that cosecant?
Oh, because we're just saying that this reciprocal function is just, it's still positive on that side because it's related to sine. Okay?
Oh, okay.
So remember CAST. Sine is positive in quadrant 2, which means cosecant is also positive in quadrant 2.
So here we're just trying to find basically, like, if it's just positive or negative. Okay.
That's it. That's why the related acute angles are easier. Okay?
It's the same
Because we're talking about the same trig ratio.
ratio, but
So if we're talking about cosine, our related acute angle is still going to be cos. It's just going to be positive or negative. Correlated acute angles, we're going to have to look at
different.
other trig ratios. So for example here, I think I already gave the example, right? I said cosine of pi over 6 is equal to positive sine of pi over 3. Correct? That's the example I gave before. I'm going to show it to you on the diagram. So these ones, so this section over here, the left section, we're talking about our related acute angles, which is what we did in Unit 5. So this is from Unit 5. So now what we're going to do is on the right side, we're going to take a look at its correlated acute angle. And remember I said, I gave you guys a hint, that has to do with the angle on the closest to the y-axis. So let's take a look at the first example. So cos of pi over 6, okay? So what is cos of pi over 6? What value does it give us?
30.
Ratio.
Oh, pi over 3. 2.
Root 3 over 2.
Shoot. Can I? Oh.
Remember your cos?
Sorry.
So remember your cos is your x value and your sine is your y value.
Yes.
So what ratio does cos of pi over 6 give us?
Someone else did the problem. I'm like, root
For the sine part?
No, cos. What's cos pi over 6?
root 3 over 2.
Mm-hmm.
There's no.
What?
What do I gotta do?
So cos pi over 6 is root 3 over 2. Okay, this is from your special triangles that we did in the first lesson of Unit
First one's
5.
cos.
No.
So your x value is cos and your y value is sine.
Oh, yeah.
I don't know if you guys remember me writing out
X, Y.
sine y. Okay? So if this is 30 degrees over here, okay, we need to figure out what sine ratio also gives us root 3 over 2. So using your special triangles, what angle gives us sine root 3 over 2? Pi over 3. Which is right there. So cos of pi over 6 is equal to positive sine pi over 3.
You did this in grade 11, right?
You didn't do this in grade 11.
So, I just have a question. Oh, you can go first.
So, you said you have to bring it to the closest y-axis, right? So,
Mhm.
once you do that, it's just gonna be pi over 3 over there, right?
Yep.
So that's our answer?
Mhm.
Okay.
It's pi over 3.
Hey, sir, but may I ask why it has to be the same ratio from a different angle, right? So again, with
Okay, so if we take the example of the related acute angle, correct? If we do cos of pi over 6, okay, and we take cos of negative, if we take the answer of negative cos pi over 6, are they going to give us the same answer? They should.
okay,
So do this on a calculator. Someone do cos of pi over 6, and someone do negative cos of pi over 6.
with cos of 5. Bro, guys, don't leave me hanging.
What's cos of 5 pi over 6?
Negative 0.86.
Okay, let's just use a decimal.
Sorry, my computer.
What's negative cos of pi over 6?
Negative cos pi over 6. Okay, it's the same thing.
Negative 0.86.
Okay.
Okay, now we did what's cos of pi over 6?
30.
Oh.
Or,
3
yeah.
over 2. And what is
Right.
sine of pi over 3?
Right, 3 over. Oh, yeah, 3. They're the same.
They're the same. Except with the related acute angle, we're focusing on the angle closest to the x-axis.
This one's on the y-axis.
But with the correlated acute angle, we're focusing on the angle closest to the y-axis, which is why we're focusing on this one and not this one anymore.
Great. Thank you.
Let's try the rest of them and see if we can achieve. So our next one is cos of 5 pi over 6. So where does cos of 5 pi over 6 land? Quadrant 2. 1, 2, 3, 4, 5. And again, I forgot to change the line thickness. So this is 5 pi over 6. Okay, and what does cos of 5 pi over 6 give us? What ratio? You can use the unit circle.
Negative root 3 over 2.
Negative root 3 over 2. All right, and now we need to figure out the correlated acute angle, which is which angle we're going to be focusing on.
This sine.
The one closest to the y-axis. Okay. So first of all, is sine positive or negative in that axis?
Positive. Sine? That's positive.
It is positive. Okay.
Excuse me.
So
Wait. Lost me, sir.
I'm gonna explain now.
Okay.
Okay. So we said cos of 5 pi over 6 is negative root 3 over 2, correct? So if we're looking at the correlated acute angle, we're technically looking at the angle pi over 3. Okay?
Oh.
So because we want to get the same ratio with the same sign, sine of pi over 3 gives us what on quadrant 2? Root 3 over 2.
But it's not negative.
So we want to make it negative. So in order for this to equal that, we have to add a negative in front of the sign. Because we already determined sine or cosine of negative 5 pi over 6 is root 3 over 2. Okay? And our correlated angle we're looking at is pi over 3. And sine of pi over 3, to start off with, is already positive root 3 over 2. But because this gives us a negative ratio, we also want a negative ratio on the right side. So that's why we have to multiply negative by sine of pi over 3. All you're doing with correlated acute angles is making sure left side is equal to right side.
Yeah, but I'm just confused on, like, why don't you just say, like, so basically, sine in the third quadrant is negative sine pi 3, no?
Which one?
Or is that 10?
What
Wait,
quadrant?
is it like the third quadrant, like that?
So 1, 2, quadrant 3 is over here.
Or-
Quadrant 3 is this one.
Yeah. So like, technically wouldn't oh, it's because you didn't write the sign, like the sign's like the one that's like you're supposed to find.
Mhm.
Oh, okay.
So remember, this is our cos, right? This is our sine. Are the signs different?
Yeah.
Okay, so we want to make them equal to each other, which means we have to multiply the sine ratio by a negative to get it to suffice left side equals right side. So remember with this, you're just finding left side is equal to right side. You can technically do trial and error, and you'll probably get the answer pretty quick. But if you use the unit circle, you should be able to get it a lot more fast. We have 3 more examples to go through, so we have 3 more chances for you guys to grasp this.
Okay. Don't forget to change by size.
Fingers crossed for the next example.
Why?
So we're only doing one lesson.
I think we might have to.
60 times.
Okay, good.
60 times 4 is 4.
So our next angle is sine of 4 pi over 3. Where does that land us in?
Third quadrant?
Okay?
Oh. Okay.
Right? Because it's 60-degree intervals. So this is 4 pi over 3. All right? So we're looking at sine of 4 pi over 3, and what does that give us?
5 over 6.
No, the ratio.
Oh, was it sine?
Yeah.
The root 3 over 2. Negative? Negative.
Negative root 3 over 2. All right? So now what would our correlated acute angle be? Pi over 6. So to make it easy, what does cos of pi over 6 give us? Okay? Do we need our root 3 over 2 to be positive or negative?
Negative.
So what sign are we going to put in front of the cos?
Oh, okay. Pretty easy.
So you want to do this first,
Okay, yeah.
okay? If it doesn't give you the same ratio as the one on the left side, you have to multiply it by a negative.
Okay, cool.
Pardon?
Why would you put the negative first?
Because it's easier to,
It might be negative.
maybe negative already, that's why. So it's easier to calculate the ratio
Yeah.
of this first and then decide if you need to add the positive or the negative
Yeah.
after. Okay, so the first thing to do with this is identify your correlated acute angle, figure out the ratio, and see if you have to multiply it by a positive or a negative for it to equal the left side. All right, so next one we have is 5 pi over 3. And what quadrant are we going to land in for this one?
Fourth quadrant.
Fourth?
Yeah.
1, 2, 3, 4, 5. Five pi over 3. Okay? So what does tan of 5 pi over 3 give us as a ratio?
Isn't it,
Remember, tan is the ratio between sine divided by cosine.
like, look at multiply? Multiply, I don't know. It's like one.
Divide by right.
What is tan? What is the ratio of tan?
3√3/2.
Wait.
Isn't it root 3 over 3?
Root 3 over 3.
Oh.
Remember, tan
Does it just take over the thing,
is equal
Y over X, yeah.
y over x,
right? Yeah.
which is equal to sine divided by cosine.
Yeah.
Okay? So we have our sine as negative root 3 over 2
Oh.
and our cosine as 1 over 2. So we just have to divide them. Okay? So
Well, my bad, negative root 3.
Yeah.
Negative root 3. We follow those.
So we have negative root 3 over 2 divided by 1 over 2, which is equal to negative root 3 over 2 times 2 over 1. And that gives us what?
Negative root 3. I think that.
Negative root 3.
Oh my bad. Is that wrong?
That's why I was confused. I was like,
All right?
you don't get it.
So
Root in this one.
what correlated acute angle are we going to look at?
Good question.
Pi over 6.
Pi over 6.
Yes.
Okay? And what does cotangent of pi over 6 give us?
You lost.
Okay, so what is tan of pi over 6? That's what we have to figure out first.
Negative root 3.
Wait, can?
Mhm.
Wait, and we just figured that out.
Nope, we figured out tan of pi over 3.
Oh, so then it would be,
Root 3 over 3.
Do we all agree with Joseph?
yeah, because he's looking in his book.
Can't argue with that logic. Okay, root 3.
So tan of pi over 6 is root 3 over 3. Okay? And what would cotangent be?
Oh my goodness, that makes sense.
So it would be 3√3 over 3.
And then you would multiply.
Did that make sense?
No, it would be 1 over root 3.
1 over root 3 over 3 would cause it to flip, no?
Yes.
Gosh, this is why I hate trig.
Pi over 6, we have this,
I hate
right?
trig.
Did you multiply right? Or did you do the ratios right, Joseph? So we have tan of pi over 6 is equal to 1 over 2 divided by
You would flip that.
root 3, right?
So I think you should just ask the chat.
So tan of pi over 6 is 1 over
Root.
root 3.
Yeah.
Correct? So what would cotangent of pi over 6 be?
Yeah, it would be root 3.
Root 3.
Which
And-
equals the value. Oh.
And because we got negative root 3, we need to multiply by a negative.
Wait, but isn't root not supposed to be at the bottom?
Yeah, but for when you do the reciprocal,
Oh, yeah.
it's gonna go back on top.
Okay, because in my thing I wrote it as 1 over root 3, but I didn't say that.
You should have said one over, it would have saved us a whole lot of time.
So really, right now, we're just using either pi over 3 or pi over 6, right?
Yeah, we're just using the general angles.
Right.
Sure. Why are we dumb? Wouldn't it still be the same thing though? Because it's 10, both of them positive. Wouldn't it just be in the first quadrant? Like,
No, tan of 5 pi over 3 is negative in that quadrant right there.
what?
So tan of 5 pi over 3 lands in quadrant 4, which means tan is negative. Okay? So we're gonna get a negative ratio. Yes.
Like, did you really, need to look at the quadrants on this one. Like, you can just look at the value and say, okay, it's negative, and then make the other one negative.
That's what I'm telling you guys to look at the points.
Yeah, so you don't even have to look at what quadrants.
You don't have to look at the quadrant. If you don't have the points of the unit circle, then yes, you have to look at the quadrant.
Yeah.
But if I'm giving you the unit circle with all the points, you just have to look at the points.
What, are you gonna give us that?
I'll see.
Oh, please, sir.
Well, you guys have your notes anyways. You guys can use
I
the.
don't cheat, sir. I'm kidding, I do it.
You should have been that.
So cohort, what is this? A and C. How confused are you?
That's only the thing, bro. Like Einstein said, boredom equals MC squared.
Sir, I'm pretty sure the other class is smarter than us.
Okay. A bit. Okay. Anyone else besides Adam?
As long as the math is-
Okay. I got 2 out of 13 responding. I need more people to
I think
respond.
we all passed out.
Was it Matthew?
We all passed out.
No, Matthew
It's
told
check
us.
my phone.
Okay. Okay.
Things weren't really strictly- Things like- and then like grade, like-
All right. So I got 100% confusion rates, which is not bad. Yeah, I did y over x. That's why I did, so for tan of pi over 6, I did 1 over 2 divided by root 3 over 2. So that's why we got 1 over root 3. And because cotangent is just the reciprocal of tan, we just flip that ratio and we get root 3.
But I have to expose.
Hey, man, like, don't wear styles.
Dog, I'm telling you, put on shoes and socks. I didn't put on shoes.
Okay, so let's see if our last example can hopefully have you guys understand it a bit more. All right, this is the last effort. So, I'll try to go slowly. So, we have cosecant of 2 pi over 3. So, where does 2 pi over 3 land in? Second quadrant. Okay. So cosecant of 2 pi over 3, what primary trig ratio are we looking at?
Sine.
Sine, because cosecant is equal to 1 over sine. So what is sine of 2 pi over 3?
Sine.
Root 3 over 2.
Okay, so if sine is root 3 over 2,
Would be 2
what
over
is
3.
cosecant?
Or 2 over root 3.
2 over root 3.
And then therefore it would be
2, 3 over 3.
yes.
2 root 3 over t, over 3.
Okay, so what?
Sorry.
So. Okay.
So I think we did do this last year, but she never really explained it to us.
Remember, Matthew, our y is our sine and our x is our cosine. And remember, tan is the ratio between sine divided by cosine.
Bro, I never even learned how to
Wait, you got
use
this
it.
wrong. Hey, okay, that's why you think it's bad. No, I don't physics is okay.
Dude, online, like, her video just sounded like she was on the water.
I think my teacher never really explained correlated angles. She
Okay.
explained related angles,
So,
but she expected us to understand correlated.
so we know cosecant is equal to 2 root 3 over 3. All right? What correlated angle are we going to be looking at now?
Cosine.
At least the
Pi over sine.
Pi over 6. Okay?
Oh.
So pi over 6 is the reciprocal of what function? Or secant, sorry. Secant is the reciprocal of what primary trig ratio? Okay. So what is cosine of pi over 6?
1 over,
Root 3 over 2.
Root 3 over 2. Which means secant of pi over 6 is?
negative.
No, 2 root 3.
3
2?
over 3.
Yeah.
Positive.
See,
Well, yeah, it's not two.
so we leave it.
So are we going to have a positive or a negative?
Well, it's positive because it's a second quadrant.
What does matter?
Oh, quadrant is not.
Just the unit circle points matter.
Oh,
I get it now. So basically,
So the x value in the unit circle is represented by the cosine ratio, and the y value in the unit circle is represented by the sine ratio. So when we have, I'm going to make room. So I'm just going to write it here. So when we have our points x and y, which is equal to, let's just say,
I know. Well, I said it's a one method. Taking over here from what we've been doing this one.
root 3 over 2 and 1/2. Our x value, root 3 over 2, is our cosine ratio, and our value 1 over 2 is our sine ratio. And this was mentioned, I believe, in the beginning of Unit 5.
please.
Did we forget?
Maybe you guys probably thought you wouldn't have to use it up until now.
Wait, for what?
Wait, sir, question. So basically,
Okay, let's go back to the.
so basically, since, like, okay, what we gotta do first is just check, like, what the correlated angle is. And then.
First, you check what ratio that gives you, okay?
Oh, no, but like, don't we have to know the correlated angle?
Yeah, so the correlated angle, so you graph it first, okay? Find your correlated angle, insert it over here.
Alright, but then when we find the ratio, like, all we gotta do basically is just,
Look at the unit circle.
like, yeah, and then whichever one has a negative, you put it. Or is it like, since the correlated angle is like pi over 6, we have to look at pi over 6, and then we just add the negative if we need to? Okay, I get it.
So with this initial theta angle, okay, you're looking at where it lands, and you're looking at the point of the unit circle, okay? So for example, let's just take cos 5 pi over 6, that landed in what quadrant?
Pi, 2.
2. So 5 pi over 6 lands right here, correct?
Yeah.
So because cos is associated with the x value in the unit circle, what is our ratio for cos of 5 pi over 6?
Pi
No.
over,
Ratio.
root cos,
Yep, what's the x value?
negative root 3 over 2.
Okay, perfect. So what would our correlated acute angle be?
Pi over 3.
So now we're going to look at pi over 3. Okay, and what does sine of pi over 3 give us? What's the y value in that point?
Root 3 over 2.
But because cos of 5 pi over 6 gives us a negative, we have to multiply sine of pi over 3 by a negative.
Okay, we're making it confusing on our own.
So
I get it.
you're graphing it out, you're looking at the unit circle, and if it's cos, you're looking at the x value. If it's sine, you're looking at the y value. And then when you find your correlated acute angle, you're just going to refer back to the first quadrant and pick which one you're using.
Wait, sir.
Yes.
Is it a dumb question? Like, what if it's like on the negative 1 and 0?
So if it was like,
Here?
Yeah, so is that like the over the pi over 12 or something like 2 pi over 12?
That would be pi.
That'd just be pi?
Because remember, this is pi over 2. This is pi, 3 pi
Oh,
over
yeah,
2,
it's 2 divided, yeah,
and-
okay, but wait,
2 pi.
so, like, what? Never mind, I don't know, like, can there be?
So,
like,
for example-
something and stuff like that?
If I said, so cos of pi gives us what value? -1, right? Correct?
Yeah,
Now, if I were to find an equivalent correlated angle ratio, there's no real, it would just be, you're just referring to this because it lands on the same axis.
but it's
So-
not a y,
Pardon?
but it's not the y.
But
But when we're referring to them in the unit circle, remember the cos is always the x value.
No. Didn't you always say we have to do it on the, for the y-axis?
Yeah, but because this lands on the x-axis, the nearest, so you can say the correlated acute angle is at pi over 2, right?
If it's sine.
Yeah, so it would be sine. So cos of pi is equal to sine of pi over 2. Is it positive or negative?
But why can't it just be the bottom?
Pardon? Because we're looking for the one closest
to the y-axis.
to the y-axis.
Isn't that
In terms of
the same
the.
distance?
Yeah, but when we always do the questions, when we're in this quadrant, we always refer to the one that is clockwise of it.
So what would be like an example of like, say for example, it's cos pi over 4, it's 45, right?
Mhm.
So would that, would it still be the same value or something?
It will still be the same concept. I would just have an angle right. I would just have a
Yeah.
arm.
So that
Right
would
there.
just be, so say for example, it's cos pi over 4, then it would be sine pi over 4?
Yep.
Okay.
Question, sure. So if it were using that like same pi, whatever, and we get there by going negative, would the closest angle then be the bottom one?
Yeah, well, you can say cos of pi is equal to negative sine of pi over 2 or sine of 3 pi over 2. Because it has two equivalencies.
Wait, so that one will both have to, whatever?
So let me just do this on a separate sheet. So we said cos of pi is equal to -1, correct?
Yeah.
Which means cos of pi is equal to sine of 3 pi over 2. Is that correct?
If you say it,
No, what's the ratio of sine of 3 pi over 2?
ratio,
Sine pi over 2.
oh yeah, it's 0, -1. It's just like,
So this is 0 pi over 2, pi, and 3 pi over 2. So cos theta is equal to sine of 3 pi over 2, or cos theta is equal to negative sine of pi over
so we
2.
always gotta do the or?
I'll accept that answer. If I'm looking for both solutions, then do both.
Right, so like if you ask, okay. Alright, that's the only thing I was confused with. Thank you.
Okay, no, because I wasn't confused, I was just asking because it's cos pi would equal sine 3 pi over 2 or negative pi over 2.
Mhm.
That's, but would the second answer be more correct because it's in the second quadrant?
Because they land on the axes, either
Oh.
or is correct.
Right, because it's the same distance from
Mhm.
quadrant to.
This
Yeah.
took not even half the lesson done, and we're already at 9:20.
Sorry, sir.
That's okay.
It's slow.
That's fine. I'd rather go slow than go by it quickly, than you guys are more confused. So these are called your correlated acute angles. We're obviously gonna do some more examples. The next is just steps to follow. I don't know if it's gonna be confusing or not. We'll see. So we have the equivalent trig functions using correlated angles. So the complement of the related acute angle is the correlated angle. It is the acute angle between the terminal arm of the angle in standard position and the y-axis. So step one, okay, we want to locate our terminal arm on the unit circle. So 4 pi over 3, where is it going to land in?
Third quadrant.
Yep, so it's 60,
Yeah.
120, 180, and 240, right?
Yep.
So this is 4 pi over 3. So step 2, we want to use the cast rule to find the sine of the original function. So secant is the reciprocal of cos.
Negative 1.
So is cos positive or negative where the terminal arm lands?
Negative.
Secant is negative. Step 3, we want to find the angle between the terminal arm and the y-axis. So if this is 4 pi over 3, what is the correlated acute angle closest to the y-axis?
Pi over 6.
Pi over 6. And step 4 is state your final answer and remember to use the cofunctions. So these are rules. So you'll obviously have this on your assignment. So sine is a cofunction to cosine, and cosine is a cofunction to sine. Tan is with cotangent, cotangent is with tan. Secant, cosecant is with secant, and then secant goes hand in hand with cosecant. So you have secant of 4 pi over 3 is equal to negative cosecant of pi over 6. Got stuck on the. So obviously you would use your unit circle to determine the ratio of secant of 4 pi over 3. And then you would have to use the cofunction cosecant to figure out if pi over 6 you need to multiply by a negative or keep it positive. So let's do B and C. So we have tan of negative 5 pi over 3. So because it's negative, are we going clockwise or counterclockwise? Clockwise. And where is negative 5 pi over 3 going to land in?
Fourth quadrant. Oh, negative. First quadrant.
First quadrant.
Wait, sir.
Yep.
If the negative outside, like if it's negative 10 pi over 3, you still go that way?
Yeah, you still go negative, you go clockwise.
Like even if the negative's outside, like
Because when you put it, when it's outside here,
yeah.
it's only when it's attached to the actual radian measurement itself.
Okay. Good.
Welcome. So from quadrant 4 all the way to quadrant 1, it is 5 pi over 3. What would our correlated acute angle be?
5, 6, or, yeah.
Pi over 6. So what cofunction is tan associated with?
Cotangent.
Hmm?
So would it be cotangent?
Yep, is equal to cotangent of pi over 6, because our correlated angle lands in quadrant 1.
Oh, yeah, that's why there's no negative.
So if the denominator was 3, then its correlated angle would be 6.
Yep, and if
It was
it's
like-
6,
yeah.
correlated angle is 3.
But if it's like 4, it'd be 4 as well.
Let's try the next one.
Agree.
So we have sine of 3 pi over 8. So you guys are probably like, how the hell do I graph over 8?
45, 45, 45.
So we have 0, okay? This is pi over 2. So this is going to be 4 pi over 8. And then we have 8 pi over 8 over here. And then $12 pi over 8. So we're basically taking pi over 4 and just adding 2 extra sections in each quadrant. So where would 3 pi over 8 land in quadrant 1? Three pi over 8.
Wait,
Yes, Yusuf.
sir. What? Why is it over 8?
Because remember, we go from 0. This is pi over 2, right? So what does 4 pi over 8 simplify into?
Oh,
Pi over
Pi over 2.
okay.
So if you ever have big denominators, just break it up into where you can simplify the major angles like pi over 2, pi, and 3 pi over 2.
Can we even like do that with the pi over 6
You can.
and like pi over 3 and stuff?
Yeah.
Oh,
So what would our correlated acute angle be?
Yeah, pi over 8.
Pi over 8.
Good job, Keith.
So we have our normal function, sine of 3 pi over 8. And what is its cofunction?
Cosine.
Cosine, and because it lands in quadrant 1, it's going to be positive. So sine of 3 pi over 8 is equal to cos of pi over 8. If you were to do that on your calculator, you would see that both left side is equal to the right side.
I got it.
So are you guys still confused, cohort A and C? Or is it slowly starting to get better?
Yeah, I thought it's all be there for some reason. No, at least.
It's getting better. That's what I like to hear.
But the moment I say that, I'm jinxing myself. It was the homework.
Oh my.
The homework is just, I mean, like, if the homework would be like, sir, I don't understand.
Okay, what I'll do after the break is we'll do, I think, 1 or 2 questions from the homework, and then see if you guys understand it after that. But we'll just finish off this sheet and then get right and get to our break. So remember that pi minus theta, pi plus theta, and 2 pi minus theta I showed you one time ago?
no. Wait, what?
Say that again, time set.
Remember pi minus theta,
Mm-hmm.
pi plus theta, and then 2 pi minus theta for your related acute angles?
Oh, yeah.
So that's what we're going to do here.
Oh.
All right. So we want to write each function as the related acute angle. So the first one we have is sine pi minus x. So we have pi minus x. Where does our terminal arm land in?
Second, this is second quadrant?
Yep. So this is pi minus x. Damn it. And this is x. Okay?
What? I don't get that.
Well, theta is just x.
So theta is x. You can write theta or x if you want.
So basically when data is negative. Okay.
So because it lands in quadrant 2, is our sine function going to
Positive.
change? It's going to be positive, right? How about our cosine? Remember, we're just referring to the angle that's in quadrant 2. And how about our tan function? Positive or negative?
Negative.
Negative 10.
We good. So for D would be quadrant 3.
Yep. So for D, Jose is ahead of the game already. It's in quadrant 3.
Everything would be tan.
He says everything will be negative except for tan, which is true.
Yay.
How about the last one, or the second last one?
Or would be in quadrant 4.
This is going to be in quadrant 4.
The only thing that's going to be positive is cosine.
So this is 2 pi minus x, and then the related acute angle is x. So everything is going to be positive except for, everything is going to be negative except for cosine. Negative 10 of x. And the last one, tan of negative theta, where is that going to land in? So we're going clockwise.
Quadrant.
Fourth quadrant. And what are our ratios going to look like?
Everything's going to be positive except for cosine. I was an educated guess.
It's the same thing as the row above,
Oh.
right? Because it's in quadrant 4. Negative 10x.
Yeah, I didn't I say that?
We said everything is positive except
Oh.
cosine.
Oh.
That's what you said.
Oh. Sometimes you don't know what to say.
When you write x, you mean theta, right?
Yeah, x theta. Same thing. Okay, I think you guys had enough for your brains to absorb. Take a break until 9:50. I'm going to look at some questions from the homework, and then we're going to do some examples together after the break.
Don't get it, brother.